All right, so this video is going to take you through where the quadratic formula comes from. And to do this, I'm actually going to go through 3 different variations of this. So bear with me. This is because I want to explain this fully, and then I will explain what your extra credit is as we go through the video. So I want to start by considering, say, this equation here. So we'll do x squared minus 4x plus 5 equals 0. And I want to start by doing this with the quadratic formula. So if you remember from class, we have the quadratic formula is x is equal to the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. And you've been shown that formula before, but probably not shown where it comes from. So why on earth should that formula tell you the value for x? So in this problem, a is equal to 1, b is equal to -4, and c is equal to 5. And so we would come over here, we'd say the opposite of b is -4. So the opposite of -4 is 4. And then in here we have b squared, make sure you put that in parentheses, minus 4 times 1 times 5, all over 2 times 1. And then evaluating this, we'll have 4 plus or minus, this would be 16 minus 20. 2 times 1 is just 2. And 16 minus 20 is -4. And then hopefully remember that when you have a square root under a negative, that means you'll have an I. So the square root of -4 is 2i. And then we can simplify that a little bit more because now we don't have any square root there. So my answer would be 4 plus 2i over 2 and 4 minus 2i over 2. And we can now do 4 divided by 2 plus 2i over 2, or here 4 divided by 2 minus 2i over 2. I guess I didn't need to split that up quite as early. 4 divided by 2 is 2, and then 2 divided by 2 is 1, so we'd have 2 plus 1i, and then 4 divided by 2 is 2, and 2 divided by 2 is 1. And so we'd have this, 2 plus 1i and 2 minus 1i. And we could probably keep the plus or minus in there. If I had been thinking more on my game, I would have done that. So that's the answer to that. We got 2 imaginary answers. I know I went through that, complex answers. I went through that really fast. Feel free to pause the video, rewind it if you want to go through that process. Now, I want you to remember what the answers were. And what I'm about to do in the next piece of paper here is I'm going to solve that equation using a totally different method that we have not covered. It's a method called completing the square. Okay, so we might bring that page back. So it's called completing the square is the name of the method. Okay, so your first part of your extra credit is going to be to, on a piece of paper or on a Word document, you're just going to write we covered completing the square. So if you want to pause the video right now and do that, you can. It's just we completed completing the square, or we covered completing the square. So that's the first thing. This is a strategy that it actually works all the time, but it's not a great strategy to use all the time. It's very limited in when it's a good strategy to use. This strategy works well when your leading coefficient is a 1 and when you have an even number in the middle. If you don't have a leading coefficient of 1, so if you have a 2, a 3, something else there, and you have an odd number, this is a terrible strategy to use. So we don't usually teach it for solving quadratic equations because it is very limited in when you can use it. It is very useful when you're dealing with circles for changing the form of a circle. There are some neat things you can do with algebra tiles that show where the name completing the square came from. You're actually physically like making a square with your algebra tiles, which is really neat, but beyond the scope of this video. So here's what this strategy does. So we would start by subtracting 5 from both sides. And so I'm going to subtract 5. 5 minus 5 is 0, and 0 minus 5 is negative 5. Now you'll notice I left this big like open space here, and you're probably wondering, why did she do that? I did that because we're going to do some scratch work, and we're actually going to add something in there. So again, this makes sense, like with algebra tiles can really make this process make sense. But what we're going to do is take the b value right here, the negative 4, and we divide that by 2. And so negative 4 divided by 2 is negative 2. And then we take that number and we square it. And negative 2 squared is positive 4. Now that process, again, if we were doing this out with algebra tiles, you could see why that worked, why you always take the b value and divide it by 2, and then you square it, and it gets you where you want to go. But again, like for now, just that's what you do. You take the middle number, divide it by 2, and square it. So I'm going to add 4 right there. Now this was an equation, right? So the left side was equal to the right side. And so whatever we do, we have to do the same thing to both sides. So if I add 4 on the left, I have to also add 4 on the right. So that gives me negative 1 on the right-hand side there. Now, here's where the completing the square comes in. Here, we would factor this. And this will factor into x minus 2 times x minus 2. Okay, I'll do a little bit of scratch work down here for that. So we have x squared minus 4x plus 4. And so we would set up our area model, and we would do x squared, and we'd have the 4. And we want two numbers that multiply to 4 but add up to negative 4. That's going to be minus 2 and minus 2. And so that factors into x minus 2 times x minus 2, which anything times itself is squared. So that's where that comes from. Now, to undo squaring, we could take a square root. That goes back to what squaring is. So if I have 5 squared and I square root it, I would be left with a 5. So what I'm going to do over here is square root this and square root this. If you square something and then square root it, squaring and square rooting undo each other, leaving me with whatever's inside. And so I'm left with x minus 2. Sorry, x minus 2. And then over here, when we take the square root, we got to remember to do plus or minus, and the square root of negative 1 is I. And then to get x by itself, I would simply add 2 to both sides. So x is equal to 2 plus or minus I. Now, if I come back over here, that is exactly the same answer that I got with the quadratic formula. Now, on this one, I have it split up, but I could split it up here as well. I could do 2 plus I and 2 minus I, so that you could see the two answers. On this one, I have the coefficient of 1, but that you can have that or not have that. And so you can see we got the same answer. So even though this process probably seemed really weird, like we were doing this weird stuff, it obviously works. Okay, it arrives at the same answer. So what I want to do now is take this process and complete it on a generic equation so that I can come up with a formula that will always work. Ready for the ride? Here is your next extra credit point. You're going to write down on your page, ready for the ride. Okay? So you're just going to write that down. Here we go. And so first point, we covered completing the square. Second point, ready for the ride. And so we are going to start with a generic equation where we don't know what the numbers are. Ax squared plus bx plus c. And then I'm going to start by what I did last time is subtracting that number. So ax squared plus bx equals 0. Oh, sorry, equals negative c because I subtracted it. So it's the same as this step right here where I subtracted the 5, except now I don't know what the number is. So now we do have a bit of an issue here because I have potentially a number out here. So before it was a 1, and I mentioned at the very beginning, completing the square only works well when there's a 1, but you're not always guaranteed that it's a 1. So I am going to divide everything by a to get that out. Whatever you do to the left, you have to do to the right. So if I divide everything on the left by a, then I have to divide everything on the right by a in order to keep it balanced. Now here the a's cancel out, leaving me with x squared. Here I have not a great thing. I have a fraction there. And over here I have negative c over a. So I'm really not thrilled with this. And now you know why people don't usually cover it. Now the next step was to take the b value and divide it by 2 and then square it. And that would be the secret number that we would add in. So here we go. Scratch work. My b value is b over a. And I would like to divide that by 2. To divide by 2 is to multiply by the reciprocal, which is 1/2. So I would have b times 1 is b over a times 2, which is 2a. Now that might ring a bell because we have seen that before. We have seen b over 2a. Usually it was in a subtraction sense, but you'll see where that comes from. So we've seen that b over 2a. That was part of our vertex formula. Okay, now you're getting an idea of where it comes from. So for your third extra credit point, you're going to write down vertex, oh my. Okay? And now you got your third extra credit point. Now we're going to take that and square it, which means we're going to do b over 2a times b over 2a, and that will give us b squared over 4a squared. And that also might look familiar because you know you've seen in the quadratic formula, you've seen like the b squared. So we're going to take this, we're going to add b squared over 4a squared, but whatever I do to the left, I also must do to the right. B squared over 4a squared. Now, this, I'm going to ask you to just take my word for it because we haven't really done a lot of completing the square. When you go to figure out what the factors are, it will always be that number. You just like save that number and that's what goes in the parentheses. So on this one, it would be x plus, and there's our like little number that we saved, b over 2a squared. On the right hand side, if I want to add those fractions, I need a common denominator. I already have a common factor of a, but this one also has a 4 and another a. So I'm going to do negative c over a times 4a over 4a. And I'm just going to bring this down to the next line. Negative c times 4a is negative 4ac. That also looks familiar. And now I have a common denominator. So now I can add that. Now when I add it, I would have negative 4ac plus b squared, but I'm just going to switch the order so that I'm not leading with a negative. I'm going to say that's the same as b squared minus 4ac. That should look familiar. So we have x plus b over 2a equals b squared minus 4ac all over 4a squared. And I am going to take the square root to undo the squaring. And this will be plus or minus. And you can really start to see the quadratic formula start to shape up. Over here, square rooting a square means that we are left with x plus b over 2a. Over here, that I cannot do much of anything with in the numerator, but I can take the square root of 4a squared. The square root of 4 is 2, and the square root of a squared is 2a. Almost done. You probably want another extra credit point in here, okay? So for your fourth extra credit point, just say, write down the words, are we done yet? Okay, so basically you're writing down on your page, Okay, you're writing down on the page what we're doing here. All right, let's finish this up. So we've got this here. So I need to get x by itself. So I'm going to subtract b over 2a from both sides. And lo and behold, we have a common denominator. So if I have a common denominator, that would be 0. And I can just combine those. So I have negative b plus or minus the square root of b squared minus 4ac all over 2a. And there is your quadratic formula. So for your last extra credit point, I want you to tell me your honest thoughts about this process in, let's say, 2 sentences. So I don't want you to just say IDK or that was awful. I'm not going to be surprised if you feel that way. IDK, that was awful. But some thoughts about, like, did you follow it? Did you not follow it? Do you appreciate where the formula came from? Even if you couldn't replicate it, that, like, at least now you know that it comes from somewhere. Just give me your honest thoughts in 2 sentences. To receive your extra credit, all you need to do is turn in this page, and I am going to ask you that since you have watched this video and you have bothered to go through this process, that you not just tell someone else what the extra credit is. So you watched it, your friends can watch it also. Do not just give them the answers to the extra credit. So I hope this was at least a little bit interesting for you, and you got a little bit of bonus knowledge about where the quadratic formula comes from.